Hi mathematicians, in this lesson we are going to be working with slope, and after this lesson you will be able to define slope, and we're going to relate it to rate of change.
We're going to learn about slope. From our work with tables, we know that the rate of change for a line is the ratio of the change in y to the change in x. Looking at this example right here, you can see it by -7 to -4 is a change. It's a +3 change. If you look at a number line, -7 is to the left of -4. You'd be going to the right. That's why it's positive. From -4 to -1, again, you're going 3 units to the right, so that's +3. Also, and then from -1 to +2, you're also going to the right 3, so +3. Looking at the change in y, you're decreasing. Easier to see with positive numbers. From 5 to 3 is decreasing by 2. From 3 to 1, you're decreasing by 2, and from 1 to -1. And again, if you need to see that, 1 is right here, -1 is right here, you're going to the left 2 units. So our change in y always at the top of our fraction, and the change in x is always the bottom of our fraction. In this case, we have that the change in y and the change in x is -2/3. We also know that the rate of change for a line is always the same. So that's why this is always the same in our table, because we are told that this is a linear function. We say that this is a constant value because it's always the same. We have another name for this rate of change, and that is slope. So it is exactly the same. Rate of change is slope. Typically, we use rate of change when we're talking about a table of values, like we were above, and when we're graphing it, we talk about slope, but they can be used interchangeably. And there's a special variable that we use for slope, and that variable for slope is m. So this is the middle of your page, and this line right here, these are the points that are plotted from your table. These are the exact points from your table. And when you look at the graph of our points, you can see the change in y and the change in x. However, most of the time when working with the graph, we use the terms rise over run. So our change in y is our change in y values, which is along our y-axis here. So you might label that in our x-axis. You can label that on either side. And that's our horizontal change for y and our vertical change for x. You can see that we use these terms interchangeably. So change in y is the same thing as rise, and the change in x is the same thing as run. And that should make intuitive sense to you. When you run, you're running across, you're not running up and down. And rising, things that rise go up and down. So the rise of a line is the change in y between any 2 points. And the run is the change in x between any 2 points. And just like our work with tables, we must reduce our ratio to ensure they have equal values. Let's look at that on our graph. So I circled 2 different points here that are not next to each other. If I do the rise, which in this case, if I'm starting here, I am going down to the next point. So I'm going down until I get to here, and then my run would be over this way. And if we count those values, this is 1, 2, 3, 4. So I'm going down 4. That's why I'm going to put a -4 there for my rise. And my run, I'm going to the right 1, 2, 3, 4, 5, 6. And it's to the right, so that's a +6 direction. So that -4 over +6 would reduce. I can divide both the top and bottom by 2, and you can see because I skipped a point, that kind of makes sense that I'm dividing by 2, and that would be -2/3, which is the same for the smaller triangle. So if I look between the top 2 points, what we have here, -2/3, and the bottom 2 points would also be -2/3. So whether you take 2 and have, between these 2 points and have to reduce, it would be the same no matter which points you choose. Even if we took the first and the last point and we counted that down, we go down 6, and then we'd go over 9, that would still reduce to -2 over 3. Just add up here at the top that your change in y is the rise and the change in x is your run. Look back at the top of your page. We're going to talk about this difference, this change in y and change in x. If I wanted to calculate this, like for example, for this one right here from 3 to 1, I could have taken 1 minus 3, and that would have given me -2 if I needed to do that in the calculator. And the same thing here for the other side, for the x value, I could have taken 1 minus a -4. We don't do that because that's more complicated, especially with our negatives. We kind of are just counting on the number line, but I can take that difference. That would work between any 2 points, and we denote that by making a generic ordered pair that represents any ordered pair in our table or on our graph. And to differentiate between them, because we wouldn't want to have two x's and two y's, we say one ordered pair is x1, y1, and the other ordered pair is x2, y2. And we put a little lowercase 2, a subscript. You might have seen that used in science class before, and it's just to differentiate between any 2 points. And I just want you to write that there. These are just any 2 points in our table or on our line. And the reason that can be important is sometimes we talk about our change in y as the difference between those. So we would say that it's really y2 minus y1. And actually, you could take the difference the other way as long as you do the same thing when you take your differences for the x values. So another way of doing your change is to actually do that subtraction. Some of you may have seen this before. This is also often called the slope formula. So write that down. I personally continue to just do the change in y over change in x, but I want you to see that, and we will talk about that a little bit more. It'll come in handy later in this unit. To summarize here, the rate of change is exactly the same as saying slope. They mean the same thing. The variable that represents slope is m, and that is the change in y or the rise over the change in x or the run. Those can be used interchangeably. And here are some details that we want to point out when we're working at slope. So always look at the slope from left to right, just like you would read. So you're going from left to right. So when I'm looking at positive slopes, you can see here from left to right, if I put my pencil all the way to the left and follow a line, if it's going up and to the right, that means it's positive slope. If I put my pencil or my finger all the way to the left and then follow the line and it's going down like it is here, that means that it is a negative slope. And you want to simplify your ratio each time. And we wanted to point out that a negative divided by a positive, that negative can be in either direction. So a negative divided by a positive or a positive divided by a negative just means that that slope is negative. So it would be falling from left to right. This would be a negative slope. However, if you are going down 1 and then left 2, like this example would be, I can look over here. If I'm going down 1 and to the left 2, it's got to be on the positive, down 1 and to the left 1. See, if I go down and to the left, I'm not on my line. But here, if I go down 1 and left 2, you would see that I'm still falling on my positive line. So that is the same thing as positive 1 over positive 2. So if I go up 1 over 2, or if I go down 1 left 2, you see I'm still on that positive line.